So today we're going to be looking at points of discontinuity. What are points of discontinuity? They're moments within a function that are undefined and appear as a break or hole in a graph. And when we say break, what we are actually talking about is an asymptote, okay? And more specifically, a vertical asymptote. How do you find these points of discontinuity? Well, it's when the value of x or whatever your variable is that makes the denominator 0, because obviously there's a mathematical law that says you cannot divide anything by 0. So if you are dividing by 0, you cannot have a value on your graph. How do you find these points of discontinuity? Well, you take your denominator, set equal to 0. Then, depending on if you have linear or quadratic, if it's linear, you just go ahead and solve for x. If it's quadratic, you're going to have to factor it and then solve for your variable, okay? So, let's take a look at our first example, finding the points of discontinuity when the denominator is linear. So, again, in this situation, all we care about is that expression right there. We want to take that expression and set it equal to 0, and now we solve for n. So add 24 to both sides, divide by 3, and n equals 8. That is where our point of discontinuity is, okay? So here, that's the expression we care about. Set it equal to 0. Solve, add the 6, divide by 3, and x equals 2. Okay, so that's where our point of discontinuity is. So that's either a vertical asymptote or it is a hole. Right now, we're not worried about that. We are just finding the points of discontinuity. And in our second example, we have quadratic, so that means we have to factor. So again, to find the point of discontinuity, we only care about that expression. So we take that expression and set it equal to 0. Now, because we have a squared term, it's a quadratic, so we have to factor it before we can solve. We can't solve it like we do linears. So here, what multiplies to negative 27 adds up to negative 6. That's going to be p minus 9 and p plus 3. Negative 9 and 3 multiply to negative 27, and they add to negative 6. And so now we take each of these factors, set it equal to 0, and now we solve for p. We get p equals 9 and p equals negative 3. So here we have 2 points of discontinuity. All right? Now, with the second one, again, all we care about is this expression right here, set it equal to 0. Now, with this one, we only have 2 terms. It is quadratic still, but the way to factor this one is to factor out the greatest common factor, which between 21 and 18 is 3. Actually, that's a lie. It's 9. No, I'm right. It was 3. And m. And so that leaves us with 7m minus 6. Now take each of these factors, set them equal to 0. And solve away. Divide by 3. And here you get m equals 0. Add 6. Divide by 7. So there are our points of discontinuity right there. M equals 0 and m equals 6/7. Okay? So what you're going to do now is you should probably go to page F19, I believe, and practice this. But we'll move on. So once we know how to find points of discontinuity, then we have to figure out what type it is. It's either going to be a vertical asymptote or it's going to be a hole. Now, vertical asymptotes, when you have factors in the denominator that do not cancel with factors in the numerator, that will be a vertical asymptote. If it's a hole, that factor does cancel. So, as you see in this example here, we have two factored quadratics on top and bottom. Okay? Here, you'll notice that x plus 2 is the same on top and bottom. So those can cancel out. So because x plus 2 cancels out, this point of discontinuity of x equals negative 2 is a whole, and the factor of x minus 1, which gives us a vertical asymptote x equals 1, does not cancel. So let's look at some examples, okay? So first thing is determine your points of discontinuity. So take that denominator, set it equal to 0. Here it's a quadratic, so factor. What multiplies to 9 adds up to negative 10. That would be negative 9 and negative 1. Set those equal to 0. And solve. You get n equals 9 and n equals 1. So your points of discontinuity are n equals 9, n equals 1. So now we have to determine which type they are, which means we need to factor the numerator. So if we have n squared minus 16n plus 63, we have to figure out what multiplies to 63, adds up to negative 16, and those two numbers are going to be negative 9 and negative 7. Okay, so now if I rewrite this fraction, we get n minus 9 times n minus 7 over n minus 9 times n minus 1. Okay, I'm looking at the factors, not what we solved for. Now, in this case, we see that n minus 9 and n minus 9 are the same on top and bottom. We can cross those out. Now, because we crossed out n minus 9, that means n equals 9 is a whole. Because n minus 1 doesn't have anything to cancel out, that becomes our vertical asymptote. So if we rewrite these in the proper category, our vertical asymptote is n equals 1, our whole is n equals 9. Okay, let's look at our next example. So again, find your points of discontinuity. Take that denominator, set it equal to 0. It's a quadratic, so factor. And we get what multiplies to 15 adds up to negative 8. That's going to be negative 5 and negative 3. Take each of those factors, set them equal to 0. And now solve, add 5 to both sides, add 3 to both sides. Our points of discontinuity are b equals 5 and b equals 3. Now we have to factor the numerator to determine what type of point of discontinuity it is. So if we factor b squared minus 9, we're looking for what multiplies to negative 9 and adds up to 0. That would be positive 3 and negative 3. And so if we rewrite the equation, b plus 3 times b minus 3 over b minus 5, b minus 3. We see on both top and bottom we have a b minus 3, which those will cancel out. Which, since b minus 3 gives us the answer of b equals 3, or the point of discontinuity b equals 3, that is going to become a whole. B minus 5 doesn't cancel out with anything on top, so that becomes a vertical asymptote. And so let's write those down here in the different categories. Notice that we didn't come up with any brand new answers for B. We're using those 2 points of discontinuity and just categorizing them into the more specific type. All right, then we got example number 3. Again, find your points of discontinuity, factor it. So what multiplies to 2 adds up to 3, and then set each of these equal to 0, solve, and you get subtract 2, n equals -2, subtract 1, n equals -1. So our points of discontinuity are n equals -2, n equals -1. Now, factor the numerator. Okay, what multiplies to 12 adds up to 8. And if you figure that out, that's going to be n plus 6 and n plus 2. So if I rewrite this fraction with n plus 6 times n plus 2 on the top over n plus 2 times n plus 1 on the bottom. Now if we look, there's an n plus 2 on both top and bottom. They cancel out. Since the factor n plus 2 got us the point of discontinuity n equals -2, that would be a whole. Because n plus 1 did not cancel out, that makes the n minus 1 a vertical asymptote. And so now, let's rewrite those in the correct category. So n minus equals -1 is the vertical asymptote, and the whole is n equals -2. All right, and so the rest of this we're going to practice from the workbook on finding the points of discontinuity and determining which type they are.